Hi guys, sorry I can't be with you today. Look, I want to take you through some exercises on page 250 of your textbook. This question's a bit like what you're going to find in question 1. Solve for x if sine x equals 1 on the square root of 2. So we're talking about an exact trigonometric ratio here, and 1 over root 2 should bring to mind this triangle here. We've got 1 square root of 2. And what are we going to talk about today? I think we're going to keep it in radians and maybe a bit of degrees too. Let's deal with radians first. But can you see, guys, from my right angled triangle there, that sine pi on 4 is equal to 1 on the square root of 2. So we can say that x equals pi on 4. But that's not the only issue here, because I forgot to mention that in all of this we're going to be interested in values from 0 to 2 pi. In other words, where in the unit circle is this true? So we've just found that x could equal pi on 4. It's not the only possibility though. If we had pi on 4 here, this is a sine ratio, and we notice that this is positive, by the way, 1 on positive root 2. So there is another possibility over here that x could equal, what's that, pi minus pi on 4, which is 3/4 pi. Okay, so we've got two solutions to our answer over the domain 0 to 2 pi. That is, x could equal pi on 4, or 45 degrees, or x could equal 3 pi on 4, otherwise known as 135 degrees, isn't it? So we've got two possibilities.
You're despicable.
Sorry, I've got no idea how that ended up in there. Let's try another one. Let's say we're talking about find all values for x, all values for x such that tan x equals negative square root of 3, and the other condition is x is between, as per usual, 0 and 2 pi. Okay, let's have a look at that one. Well, it seems to me we're going to need this triangle here, the isosceles triangle. Now we've got 1 there, 2 there, square root of 3 there, and we're talking about negative root 3, so that's root 3 on 1, isn't it, with a negative, so that's going to be 60 degrees there, or pi on 3. Okay, so now this is the thing, we are talking about the tan ratio being negative. So the tan ratio is negative in the second quadrant and the fourth quadrant. So it seems to me theta would be in that quadrant pi on 3 there and pi on 3 there. Okay, so how do we do that? Well, we simply subtract pi on 3 from pi. So in this quadrant here, it's going to be x equals pi minus pi on 3, which is equal to 2/3 pi, or 2 pi on 3. And also, and this one here, we can say is equal to 2 pi minus pi on 3. So that's like 6 pi on 3, isn't it? Take pi on 3 equals 5 pi on 3. Okay, so two possible answers, 2 pi on 3 and 5 pi on 3. Now fellas, what you can do is have a go at question 1 on page 250. Press pause and I'll set you up for the next piece of work in 5 minutes. Okay, I hope you've checked your answers. Let's move on a bit. This one's a lot like the the sort of question you'll find in question 5 on page 250. So let's have a go at that. Okay, the first thing I would do here is get rid of the square root of 2. So you've got 2 sine x equals negative root 2. And then you'd simply divide both sides by 2. So sine x equals negative square root 2 on 2. And then you'll go to your triangle and you'll notice you've got a bit of a problem. So let's see how we're going to get around that. We've got 1 there, 2 there, and square root of 3 there. So that's a pretty useless triangle actually. Let's try this one. And we've got 1 right angle there, root 2. You'll notice you can't get sine, equal root 2 on 2. No way. So what happens, however, if you rationalise the numerator? In other words, you multiply that negative root 2 on 2 by the square root of 2 on square root of 2. Because remembering, when you rationalised surds, what you did, you rationalised the denominator, but that square root of 2 over the square root of 2 is 1, isn't it? Anything divided by itself is 1. So you haven't changed its value, but you've done something quite useful here. And so what we're going to find is that root 2 times root 2 is simply 2 on 2 square root 2. Now the 2's here, these 2's I'm talking about, will cancel each other out, and you've got 1 over the square root of 2. Now, we notice that in our right angled triangle, that sine pi on 4 is equal to 1 on the square root of 2, isn't it? So we found one of our answers. X could equal pi on 4. So of course pi on 4 is just one solution. For x, we were talking about the sine ratio, so once again our second solution could be pi minus pi on 4 to give you that angle. So our other solution is, so we can say x equals pi on 4 and also pi minus pi on 4, which equals 3/4 pi. Okay, that's that one. Now you can have a go at question 5 on page 250. Okay, you can have 10 minutes to do that, and I'll be back with the last section of work. Alright fellas, a slightly messy one here in the pretty pink colour. Look, what we do often in mathematics when things get messy is put in a temporary device. So what I'm going to say is that I'm going to replace all this half bracket x minus 20 with a very nice simple a. Okay, that's going to make things a little bit easier. So I want to find the value of a. Now when I press shift cos negative 0.4 on my calculator, I discover that a is equal to, well, in degrees, yeah, this is like from question 8 on page 250, and they're talking about degrees, so we're digressing to degrees for a minute. But anyway, a is equal to 113.57 degrees to 2 dp. Okay, so that's what a is equal to. Now, really what I can do now is let 113.57 equal that and solve for x. I could do that, but I'm not going to, because what I'm going to do next is find the other value for a that could exist in my unit circle. So just very roughly, if a is, one possibility for a is 113.57 degrees, it's an angle like that, isn't it? An obtuse angle like so. And remember, all stations to central. So that makes sense, that angle there, because the cosine is definitely negative in the second quadrant. So that's good. Now, let's have a look at this angle here. 180 take 113.57 is to do 2 dp. It's equal to 66.422 degrees. Okay, so that's that little angle there. I'll put it in yellow. Okay, now if I add that 66.422 degrees to 180 degrees, I then get that angle, don't I? And the cosine ratio is negative in that quadrant. So another possibility for A is 66.422 plus 180 degrees, which is equal to 246.422 degrees. Now, unfortunately, that's not my answer. That's the possible values for A. But A is equal to a half bracket x minus 20, isn't it? So really, all I've got to do now is solve for that. Okay, so let's get a new sheet going. So, looking at the first possibility of A equaling 113.57, we find that x therefore must be, well, let's times both sides by 2. And I think we'll get 227.14 equaling x minus 20. Then we just add 20 to both sides and we'll discover that x is equal to 247.14 degrees. Now for our second possibility of A equaling 246.42, we can, I don't know why that arrow is there, but anyway, ignore it. We can times both sides by 2 again and conclude that 492.844 is equal to x minus 20. Therefore, x is equal to, well, just add 20 to both sides, and you will get 512.844. Okay, so I've got two possible answers, of course. X could equal 247.14 or 512.844 degrees. That's to do 2 dp, and this should be as well, so let's knock off the last 4 there, 2 dp. Okay, you are ready now to have a go at least 8 questions from question 8 on page 250.